Polymorphism is my favorite kind of morphism. As morphism goes, polymorphism is the hottest morphism. All right. Here we get to examine our use of language. Polymorphism, what does it mean? Poly, what does poly mean? Anyone? Many. Right. Morph, what does that mean? Change. Ism.
It is
A man should not believe in an ism. He should believe in himself. I quote John Lennon. I don't believe in Beatles. I just believe in me. After all, he was a walrus. All right. We've got an animal, mammal, dog hierarchy. Can we treat a dog as a mammal? As a mammal? Yeah, right? A dog's a mammal. So when you're talking about a dog, you can just do anything with a dog that you can do. You can do anything mammalian with a dog that you can do with any other mammal. Like mammals have hair and fur, right? So you could say like, you could put a get fur method on mammal and it would work for all of the mammals. Dogs, I guess dolphins have it, people, I think. All right, so if we have a dog and we just have this abstract mammal, but all we care about is the mammal parts of a dog, and we try to do mammal things to it, like count ear bones, then if you're just looking at a mammal, you could do it with a dog or a cat or a whale or a dolphin or a prairie dog. But if you have one of those things, if you have a mammal and you do mammal things to it, you don't know if it's a dog, you don't know if it's a cat. So you can't call the dog methods on it, you can't call the cat methods on it. We did this a little bit with our interfaces on Wednesday. All right, so how about architect and developer? If we treat an architect like a developer, then we can't do the architect things to the developer. If we declare, here, if I go into the code and I declare, so we're going to have another developer. That developer is Medina. She is a developer. She's a developer. Equals new developer. Medina, age 25-ish. We can do all the developer things. But what if we have an architect, Kinesis, all right. So now I've declared a developer, Medina. I use the developer constructor. And I also declared a developer called Kinesis, but I use the architect constructor. You can see that compiled. What's going to happen? When I go to create a new developer for Medina, what code gets called there? On this line. The developer constructor, that's right. So then I do all the developer things. What about for Kinesis? When I go try to create a new developer for Kinesis and he's an architect, what code gets called there? Yeah, the default constructor for architect, though. Even though we're saying he's a developer, we can use the architect constructor because architects are developers, right? An architect is a developer. It's a team lead and it's a developer. So this is the many forms piece of it. An architect in one form is an architect, but we can treat it as a different form as a developer. So now when I go and try to do developer things for Medina, we know that that'll work because we created her as a developer. But when I try to go do developer things for Kinesis, dot estimate story points, that's fine. And now what's going to happen if I try to do an architect thing? I remember that architects could evaluate vendors, right? Let's go back and look what an architect can do. Create a tech roadmap, evaluate vendor. Let's do evaluate vendor. All right. Kinesis is an architect. So let's go try to evaluate a vendor. All right, we got a big red one. No idea. IntelliJ doesn't know what I'm trying to do. And the reason is, even though Kinesis is an architect, we told Java that we wanted a developer. So it's given us a developer. So we can only do the developer things. And that right there is the old polymorphism. We saw this when we did, we talked about declaring an array of an interface type. So the interface, you can't instantiate something that is an object of type. There's no constructor on an interface type. You have to construct a concrete class that implements the interface. But when you give it a type, when you declare it, you can declare it as the interface type. And then you can only call the methods on it that the interface type exposes. Now now let's try to do this. Team lead, who's my team lead? Jamal. New developer. Oh no! Because a developer is not a team lead. A team lead is a developer.
See why you weren't.
See? Polymorphism, right? It means that a developer can have many forms. A developer can take the form of this developer. A developer can be of the form team lead, or a developer can be of the form architect. You can treat an architect as an architect, a team leader, or a developer. You can treat a team lead as a team leader or a developer, or a staff member. So over here, you need the more general one. Let me think about that. Yep. And then over here, you can have a more specific one. Or you can just, as in the case of Medina, same type. All right, and now we can do our old array. We can do an array of staff members, right? Staff member, my staff equals and then I'm going to use my enhanced for loop to iterate through the staff members. So someone will help me out. Or we can use the traditional for loop. All right, great. And now I'm just going to print out the name of all of my staff members. Does a staff member have a name, actually? What do they have? They do. Get name, like that. All right. So what this is going to do is it's going to run into this loop. Uh-oh, I got a problem. I never assigned anything to staff member. My staff 0 is Medina. My staff 1 is Kinesis. My staff 2 is Jamal. All right, so now I've instantiated an array of staff members, size 3, and then I assign Medina, Kinesis, and Jamal to the elements of that array. And now when I run through it, null, Kinesis, Jamal. That's kind of interesting. What happened there? Where's Medina? I gave her a name. What happened to it? Let's go look at it. It's in the developer constructor. I've got a name. I gave her the name. Why didn't this work? There is a get name on staff member. And there is an instance variable in staff member called name. And there is another declared instance variable in developer called name. So we're treating Medina as a staff member, and so we only have access to the staff member things. But when we created her as a developer, we set the name that's on developer. See, on developer, there's this name, and on staff member, there's also name here. So when we tried to go get the name of Medina, but we were treating her like a staff member because of polymorphism, we looked at this name. We called this get name, and we printed the name associated with that get name. And that is not what I wanted to show you, but that's what happened. Good talk, everyone.
Well, how would you make it print her name?
So what I would do is, because this name in developer is already defined in staff member, I would just take that out. And that's right, because name here on developer is a protected member of staff member, which is the parent class. So now name is available to developer. So let's see if that works. Yeah, so when you end up with this in code, you won't define it like this. It won't all be together. You'll be passing things around into methods. And so the point is that you're not going to care whether your staff member, for some operations, you're not going to care whether your staff member is a developer or a team lead or an architect. For some practical operations, you just have to treat everyone like a staff member, even though they can do other things. So if I want to like run payroll, right, maybe a staff member has a salary. And if I want to run payroll, I've got all of this stuff going around my code. I've got architects, I've got team leads, I've got accountants, but I just treat them all like staff members, and then I can run payroll for them.